Exercise 8.1 of Mathematical Methods by S.M. Yusuf. In these questions of exercise 8.1, we have to see that the given sequences converges or diverges. If they converges, we have to find out their limits. So in the exercise 8.1 part 1, we did question number 1 till question number 7. Now we need to start from question number 8. That is, we have the given sequence, nth term of the given sequence, that is ln n plus 1 over square root of n. Given nth term of the sequence is ln n plus 1 or under root n, we need to check whether it is converging or not. Apply the limit n approaches to infinity, ln n plus 1 over under root n equals to. Now, if we directly apply the limit here, it cannot be solved. We need to just finding the limit, we need to apply the L'Hopital rule here, because it will form the indeterminate form if we directly apply the limit here using the L'Hopital rule. Now you know that what is that rule? That is already explained in the calculus by S.M. Yusuf in that exercises of limits. It is already explained there. In the L'Hopital rule, you have to take the derivative of the numerator separately and take the derivative of the denominator separately. The limit will remain as it is. Take the derivative of numerator. We know that the derivative of ln x is 1 over x. So it is 1 over that function. And what is that function? N plus 1 into derivative of that function is 1 plus 0 divided by the derivative of denominator. The denominator is here n raised to power 1 by 2. Its derivative will be power down power minus 1, and without power derivative will be 1 here. This thing will be equals to limit n approaches to infinity 1 over n plus 1 divided by, if we just minus it, will get 1 by 2 n raised to power minus half. This will be equals to limit n approaches to infinity 1 over n plus 1 divided by, this thing will become 1 over 2 under root n, like this. Now we need to simplify it, and it will be simplified as, we know that this main division can be replaced by the sign of the division. This thing will become limit n approaches to infinity 1 over n plus 1 division 1 over 2 under root n. Now change this division sign into the multiplication. It will convert like limit n approaches to infinity 1 over n plus 1 multiplied by 2 under root n over 1. So it just became limit n approaches to infinity 2 under root n over n plus 1. Now we know that this n can be written as under root n into under root n. I can take under root n common. To simplify it, it will become under root n common. I will get here under root n plus 1 over under root n, like this. This will be cancelled with it. So I will get limit n approaches to infinity 2 over under root n plus 1 over under root n, like this here. Now if I apply the limit here, so 2 over infinity, this thing will become infinity, and 1 over infinity will give you the 0. So 2 over infinity will give you the answer here, 0. So the sequence converges. The sequence converges to 0. Or you can write it like the sequence converges and its limit is equals to 0. Question number 9. The nth term of the sequence given in question number 9 is e raised to power n over n. Apply the limit n approaches to infinity e raised to power n over n. This can be easily simplified. This limit can be easily evaluated using the L'Hopital rule again. And what is that rule? You have to take the derivative of the numerator separately and derivative of denominator separately. Limit n approaches to infinity, it will become e raised to power n as it is if we take its derivative, and derivative of this n will become 1 here. So it became limit n approaches to infinity e raised to power n. Now if I apply the limit here, e raised to power infinity will give you the undefined answer. This is undefined. So it means your sequence diverges. The sequence diverges. Question number 10. ln n minus ln n plus 1. Limit n approaches to infinity, ln n minus ln n plus 1. This will be equals to limit n approaches to infinity. We know that this is a property of natural logarithm. If we have two separate natural logarithm, we can combine them. It is subtracting, and with which this subtraction is, it is with this second function. So it means it will be written in the denominator. And the first thing that have the positive sign will be written in the numerator and with one ln function like this. So it can be as, we can take this ln outside like this, and the limit n approaches to infinity over into on n over n plus 1 like this. It will become ln limit n approaches to infinity. Now I can take n common outside from the denominator. It will become 1 plus 1 over n like this. This n and this n will be cancelled. We'll get ln limit n approaches to infinity 1 over 1 plus 1 over n like this. We know that 1 over infinity will give us 0. And 1 plus 0 will give us 1. And 1 over 1 will give us again 1. So we got in our answer ln 1 here. Because this term goes to 0. So we got ln 1, and we know that ln 1 is equals to 0 always. So the sequence converges. Converges to 0. Question number 11. Sine square of n over n. It will become limit n approaches to infinity sine square of n over n. It can be evaluated using two methods. The one of the method is limit n approaches to infinity. We know that sine square of n can be written as sine n whole square over n. And it can be written as limit n approaches to infinity sine n over n into sine of n. This will be separated as limit n approaches to infinity sine n over n into limit n approaches to infinity sine of n. We know that this term has the value equals to 1. And if we apply limit sine infinity here, this will become undefined. So it means out of this method we will get the undefined answer. So this is not the proper way to solve this limit. So we will follow the next method here. And the next method here is